Now, sometimes they ask you to prove identities. Let's start with a simple example in that, relatively simple. Let's say you've got question number 13 here. Or can we find an easier example on that? Let me see. Identity. Okay, that's all right. Let's start with this. Question number 13 from the worksheet. We discussed the other day what identity means, right? Identity क्या होती है? Identity और equation में क्या difference होता है? Identity is true for all values of x. Equation is only true for some specific values of x. This is an identity. That means the left hand side and the right hand side, they're always equal. They're just, the right hand side is just another way of writing the left hand side. इसको अगर आप किस तरह से change कर लें तो उसको इस form में लिख सकते हैं. That's what it means. Okay. Now we are asked to prove this identity. Now that means we somehow need to show that the left hand side here is equal to the right hand side. That's what we need to do. Okay. इसको किसी तरह से कन्वर्ट करके आपने इस तरह कर देना है, या फिर आपने ये शो करना है कि राइट हैंड साइड इज इक्वल टू द लेफ्ट हैंड साइड. दोनों में से एक चीज कर सकते हैं, कोई भी किसी भी साइड से स्टार्ट करके आपको प्रूव करना है कि वो दूसरी के इक्वल हो सकती है. ओके. Now, generally, what you're going to do is you are going to start from a side that is relatively more complex. You're going to start from a side that is relatively more complex. Now, let me just write that down here as well. Start from a side, from the side that is relatively more complex. Now, how would you define complexity? How do you say that this side is more complex? Sometimes you just figure it out by looking at this. So in this case, it's pretty obvious. कौन सा ज़्यादा complex लग रही है? The left hand side, right? The left hand side has more number of terms. It has two terms. The right hand side only has one term. Okay. The left hand side has two different functions. One is sine and the other is cos. The right hand side only has one function. That's cos. Okay. तो आपने देखना कौन सी साइड ज्यादा कॉम्प्लेक्स है. सो वन थिंग दैट यू कुड लुक एट दिस पॉइंट वुड बी कॉम्प्लेक्सिटी का जो रिप्रेजेंट कर रही होगी चीज, मोर कॉम्प्लेक्स कौन सी होगी? जहां पे डिफरेंट टाइप्स ऑफ फंक्शंस होंगे. Different types of functions, that could be one thing that you could look at. Another thing could be that you have more number of terms on that side, right? That could be another thing. So right now you've got two terms on the left side, one on the right side. Another thing that you could look at could be which side has fractions. Sometimes you'll have fraction on one side and you would not have a fraction on the other side. So जहाँ पे fraction है, you would start from that side, because fraction को खत्म करके एक simple expression बनाना आसान होएगा as compared to एक expression को fraction में convert करना. That's going to be more difficult. Okay, so more complex side कौन सी होगी? These are some things that you can think of in your mind. The side that has more functions, यहाँ पे the left hand side has two functions, the right hand side has only one function. The side that has more number of terms, left side has two, the right hand side has one in this case. And the side that has fractions, that is relatively more complex. यहाँ पे दोनों में fractions है, तो यहाँ पे तो इससे compare नहीं कर सकते, but we'll see other examples जहाँ पे एक side पे fraction होगी, दूसरी side पे नहीं होगी. तो जहाँ पे fraction है, we should start from that side. Okay. Now let's look at this. We've got two sides of this identity. Now there are three ways of actually looking at this. One idea could be that you start from the left hand side, as we said, and you prove that equal to the right hand side. Another idea could be that you start from the right hand side and you put that prove that that's equal to left hand side. ये दोनों आप कैसे decide करेंगे, ये दोनों ऊपर भी discuss किया, complexity के basis पे. Now sometimes what's going to happen is both sides are going to be quite complex. उसकी वजह से क्या होएगा, आप एक साइड को जब सिंप्लीफाई करने लगोगे तो वो दूसरी साइड के इक्वल आपसे नहीं आ रही होगी फॉर सम रीजन. ओके, अब एक साइड से स्टार्ट करोगे, वो दूसरी साइड आपसे डायरेक्टली नहीं बन रही होगी. उस तरह के केसेस में विल कम टू दोज एग्जांपल्स लेटर एज वेल, बट उस तरह के केसेस में आप क्या करते हो, यू स्टार्ट फ्रॉम बोथ साइड्स. मतलब you do one side once and then you can't figure it out, you can't convert that to a form that's equal to the right hand side. So what you do at that point is you start simplifying the right hand side as well. तो अब दोनों को थोड़ा थोड़ा simplify करते हो and then you meet somewhere in the middle. दरमियान में कहीं पे जाके वो दोनों के equal हो जाते हैं. That's something that we will need to use sometimes as well. Maybe not in paper one, but when we do P3 trigonometry next, वहाँ पे थोड़ी ज़्यादा complex identities होती हैं, तो तब ये आपको अक्सर करना पड़ेगा. So keep this in mind when we reach that point. ये भी कर सकते हैं. This is also a possibility. There's one thing that you should never do when you are proving identities, and that is you cannot take terms from one side to another. ये नहीं कर सकते कभी भी. Do not take terms from one side to another while proving identities. ये नहीं करना कभी भी. The reason for that is they've asked you to prove this identity. कि left hand side is equal to the right hand side, is identical to the right hand side. आपने prove करना है वो. अगर आप इसको उठा के right side पे ले जाते हैं और इसको कहते हैं this becomes minus cos x over 1 plus sin x, और फिर आप इसको simplify करने लगते हो आगे, that would be you assuming that this is true, right? वो आपने already assume कर लिया कि identity true है. अगर आप इसको एक साइड से दूसरी साइड पे लेकर जाते हो तो आपने वो नहीं करना. आपने तो ये प्रूव करना था कि लेफ्ट साइड राइट हैंड साइड के इक्वल है, तो आपने इस तरह से नहीं करना कि एक साइड से दूसरी साइड पे कोई चीज ले जाओ. इज दैट ओके? एनी इश्यूज विद दिस? ऑलराइट, नाउ लेट्स look at this particular example to understand how this process works. Let me actually copy it to the next page. वैसे कर लेते हैं. Okay, let's do that question number 13 now. So this is an identity that we have to prove. So first of all, we think about which side we should be starting from. We discussed this earlier. We should be starting from the left-hand side because that's more complex in this case. Let's start from that side. 1 plus sin x over cos x plus cos x over 1 plus sin x. This is what we have on the left-hand side. Now, what you're going to do is you're going to use those two identities that you are given that they are true. Cos sine square theta plus cos square theta, that is identical to 1. This is one identity that you know to be true. And the other is tan theta identical to Sine theta over cos theta. Okay, you have to use those two identities to go from this expression to this expression. So it's you'll figure out when you're doing this, it's sort of like a puzzle कि आपके पास एक starting point है और ये आपके पास end point है. You're starting from one point and you're ending at another point. And these are the paths that you can follow for that. आप एक चीज लगा सकते हो, फिर आप दूसरी चीज लगा सकते हो. And just like a puzzle, you'll figure out a lot of times what would happen would be you will start going in the wrong direction sometimes. And then you'll have to figure out कि अच्छा ये इस direction में जाके I'm not getting to the correct result. You'll have to come back and start doing something else then. Okay? तो अक्सर इसमें होता है आपको स्टार्ट में नहीं पता होता, आप एक्सपेरिमेंट कर रहे होते हो क्वेश्चन के दरम्यान में कि अच्छा ये कर सकते हैं, ये कर सकते हैं. कीपिंग इन माइंड कि आपको एंड रिजल्ट क्या चाहिए, एंड पे आपको ये चाहिए. This is something that you have to keep in mind कि अच्छा अगर आप किसी और डायरेक्शन में जा रहे हो, if you're not getting closer to this, maybe you need to change your path, do something else. तो वो आपको करना पड़ेगा अक्सर आइडेंटिटीज प्रूव करते हुए. Let's try this. 1 plus sine x over cos x plus cos x over 1 plus sine x. We've got two terms here. Right side we have one term. One starting point could be that we just take LCM and make it one single term first. Okay. वैसे तो और इसको simplify नहीं कर सकते ना directly और कुछ भी नहीं कर सकते. So we take LCM for of these terms. What does that give us? That gives us cos of x into 1 plus sine x. In the numerator, we have 1 plus sine x whole squared plus cos x into cos x, that is cos square x. Is that okay? Now we simplify the numerator. 1 plus sine x whole squared. What's that? 1 plus sine square x plus 2 sine x, or 1 plus 2 sine x plus sine square x plus cos square x. Another thing, while you're proving identities, you should not simplify the denominators as long as you can do that. Okay? Denominator को simplify नहीं करें. ठीक है? Why? Because a lot of times you'll find out 2-3 steps करने के बाद कोई cancellation हो रही होगी. अगर आप denominator को simplify कर देंगे ना, तो फिर वो cancellation का लिए सोचना आपके लिए थोड़ा मुश्किल हो जाएगा. फिर वापस दोबारा से common लेना पड़ेगा, फिर cancel करना पड़ेगा. So denominators को शुरू में simplify नहीं करना आपने, उसको as it is रखना है, just to see कोई cancellation तो नहीं हो सकती है. तो यहाँ पे देखें, अगर हमारे पास न्यूमरेटर में क्या है, cos x into 1 plus sin x. Now we think about what we can do in the numerator. इसको simplify करना है किसी तरह से. क्या करें? We have sine square x plus cos square x here. What's that? This is 1, right? तो हम इसकी जगह पे लिख सकते हैं 1. So this becomes 1 plus 2 sine x plus 1 divided by cos of x into 1 plus sine x. All right? Now this becomes 2 plus 2 sine x divided by cos of x into 1 plus sine x. Now keep in mind, what do you want at the end? You want 2 over cos x. In the numerator right now, you've got cos x into something else. You need to get rid of this somehow. इसको खत्म करना है किसी तरह से, और न्यूमरेटर में आपको सिर्फ 2 चाहिए. So can you think of what we can do here? अब क्या कर सकते हैं? 2 कॉमन ले लें. अगर हम 2 कॉमन ले लें तो क्या होगा? हमारे पास 1 plus sin x आ जाएगा यहाँ पे डिनोमिनेटर में. We've got cos x into 1 plus sin x. You've got the same thing in the bracket. This gets cancelled and you're left with 2 over cos of x, and that's exactly what you had to prove. That's equal to the right hand side. This is how you prove identities. Any problem with this? No? Do we need a break or we can move on? Should we end at 3:30 or have a break right now? End at 3:30, raise your hand. Okay, so that's all of you. All right. Let's do a couple more examples quickly and then we end at 3:30, okay? Okay, this was question number 13 from the worksheet. Now, Feroza, which question did you have? Question 9. Let's do that. Question number 9, that is on proving identities as well. Let's try this. All right, so we need to prove this identity. 1 minus tan square x over 1 plus 2 tan square x equals this. Now, which side do we start from? Left hand side. Why? More complex? What is telling you that it's more complex? It has left hand side as a fraction, right hand side does not have a fraction, right? So it's going to be easier to go from left to right as compared to the other way around. So we start from the left hand side. Now let's write the two identities that we have on the side. So we know we can use them. Sine square theta plus cos square theta is identical to 1. And tan theta is identical to sine theta over cos theta. Now, how do we start? 1 minus tan square or 1 plus tan square, we can't really simplify it any way directly. कुछ भी नहीं कर सकते अभी शुरू में तो. So we can start by converting tan to sine over cos. Directly और तो कुछ भी नहीं कर सकते अभी. We could think of applying this identity 1 plus tan x into 1 minus tan x, है ना? A plus b into a minus b, that's a square minus b square. But that's not really helpful. We can't do anything after that. We're stuck here. We can't do anything after this. So what else can we do? What else can we do? Any ideas? देखिए आपको शुरू में देख के नहीं पता चलेगा हमेशा कि अच्छा अब ये करना है. You'll have to start doing something and then after a couple of steps you'll figure out कि अच्छा this is going in the right direction or not. We can do simplified or not. Yes. We can't do that. We can't do that in identities. We said earlier we cannot take terms from one side to another. We can also not divide or multiply both sides by something because that would be assuming that this identity is true already. Okay, so we can't do that. Yes, Adina. Yeah, so we can start with that. We can say tan square x is sine square x over cos square x, right? We do the same thing in the denominator as well. 1 plus sine square x over cos square x. Make sense? Now, both in the numerator and in the denominator of this bigger fraction, we can take LCM, right? If we take LCM, that leaves us with cos square x minus sine square x over cos square x. This is the numerator of the bigger fraction. In the denominator, we have cos square x plus sine square x divided by cos square x. Does that make sense or is it Too complicated to write this way? You want to write it separately? Yeah, this is okay. How many of you prefer writing this way as compared to writing it like this? Cos square x minus sine square x over cos square x, then this whole thing divided by cos square x plus sine square x over cos square x. How many of you prefer number one and number two? One, the one on the left hand side. Two. Okay, all right. Let's do it that way. Let's not make it too complicated then. Let's write it separately like this, because we've got fractions in the numerator and also in the denominator. We could write it like this. We could say this is 1 minus sine square x over cos square x. This whole thing divided by 1 plus sine square x over cos square x. Is this all right? But remember, we can't interchange the numerator and denominator right now. कि division हो रही है, इसको multiplication करके अभी हम कोई interchange नहीं कर सकते unless we first make it a single fraction. इसको single fraction बनाने के बाद फिर हम वो multiply का sign लगा के numerator और denominator को interchange कर सकते हैं. अभी नहीं कर सकते. पहले LCM लेंगे, उसके बाद उसको कुछ और करेंगे. Okay? And if you're writing it like this, please make sure that you're using these brackets properly. The whole thing should be inside brackets. Okay? Otherwise, फिर आप next part में कोई ना कोई careless error कर देंगे. The whole thing has to be in brackets. Now let's simplify both of them. दोनों में LCM ले लेते हैं. First का LCM अगर लेते हैं, that gives us cos square x minus sine square x divided by cos square x divided by cos square x plus sine square x over cos square x. And now we could change the sign. We could write it like this: cos square x minus sine square x divided by cos square x multiplied by cos square x over cos square x plus sine square x. Is this all right? यहाँ तक के मसला? No? Now we can do some cancellation. Cos square x and cos square x, they get cancelled. Cos square x plus sine square x, what's that? That's 1. So ये पूरी चीज 1 बन जाती है. What are we left with? We're just left with cos square x minus sine square x. So we have simplified this fraction on the left side to just this. Any problems with this? No? Let's look at what we want now. We want 1 minus 2 sine square x. So that's something only in terms of sine square. We have cos square x minus sine square. So we need to get rid of cos square somehow. Cos square की जगह we can write 1 minus sine square. So this becomes 1 minus sine square x minus sine square x. And that gives us 1 minus 2 sine square x, which is what the right hand side is. ये आपने prove कर दिया. Is that okay? No problem? Okay, let's do another one. All right, we need to prove this identity now. Sin x tan x over 1 minus cos x equals 1 plus 1 over cos x. Which side do we start from? Now, here we have sort of a conflict because left side we have one term, right side we have two terms, but on the left side we have three different functions. On the right side we only have one function. So the functions thing takes priority because three functions को one में convert करना is relatively simpler as compared to converting cos to sine, tan, and cos somehow. Okay, the left hand side से start करेंगे, and that's actually going to be most of the cases. ज़्यादातर आप left hand side से start कर रहे होगे in the identities that are given. Okay, left hand side equals sine x tan x over 1 minus cos x. These are the two identities that we have. What do we do? Cos में convert करना है सब कुछ eventually. What could be the starting point? Can we do anything to the denominator? Cos है, उसको तो कुछ भी नहीं कर सकते as such, right? Cos square होता तो maybe we could convert it to sine square if that could help. But this is just cos. The new denominator में we can't do much. What about the numerator? Remember ये वाली identity कब लगती है? जब स्क्वायर होता है. Sin square और cos square. We don't have any squares here. तो वो तो हम नहीं अप्लाई कर सकते. अगर वो अप्लाई करेंगे उसमें स्क्वायर रूट आ जाएगा. That's going to just make things more complicated. So you have to use this somehow. But where exactly? क्या करें? Tan को replace कर दें. That could be a starting point. Let's replace tan with sin x over cos x. Okay, we could start with this. Now this whole thing over 1 minus cos x. Is that okay? अब क्या करें? वो तो कर लिया. Cos x को नीचे ले जाए denominator में. Okay, so we could take this thing to the denominator. Right, this will go here, and this becomes sine x into sine x is sine square x. In the denominator we have cos of x into 1 minus cos x. As I said earlier, it's better not to simplify the denominator in the first few steps just to see if there's any cancellation that's possible later. उसको as it is रहने the denominator को उसको simplify नहीं करना आपने. ठीक है? अब क्या करें? Sin square x को 1 minus cos square में कर दें, and then you'll have everything in terms of cos at least. So we would have gotten rid of sin and tan. Sin square को अगर हम cos square में कर दें, this becomes 1 minus cos square x over cos of x into 1 minus cos x. What now? देखिए हमें क्या चाहिए एंड पे? एक 1 over cos x वाली टर्म है और एक सिर्फ 1 है. So denominator में we need only cos x somehow. So we need to get this cancelled किसी तरह से. 1 minus cos x. We can apply the identity numerator जो है 1 minus cos square x. We could think of it as 1 square minus cos square. That's a square minus b square. Right? A square minus b square वो क्या बन जाता है? A plus b into a minus b. So 1 minus cos square x could be written as 1 plus cos x into 1 minus cos x divided by cos x into 1 minus cos of x. अच्छा, यहाँ पे there's one very common error which a lot of people end up doing in the exam. They just look at this and they say कि अच्छा ये 1 minus cos square आ रहा है numerator में, 1 minus cos x denominator में. They cancel this with this somehow, and they have 1 minus cos x over cos x then. You understand this is wrong, right? Or is this okay? मनी भाई एग्जाम में करना नहीं है, हंस रही हैं आप, एग्जाम में नहीं करना है, ये नहीं कर सकता. दिस कैंसिलेशन इज नॉट पॉसिबल. 1 - cos x, ऊपर वो कैंसिलेशन सिर्फ तब ये वाली कैंसिलेशन सिर्फ तब हो सकती थी अगर ऊपर हमारे पास 1 - cos² x के बजाय इस तरह होता, 1 - cos x होल स्क्वायर्ड, देन वी कुड डू दिस कैंसिलेशन. अभी सिर्फ cos के ऊपर स्क्वायर है, इसमें ये नहीं कर सकता. Does that make sense? Okay. So this is what we do instead. 1 - cos² x था, उस पर हमने वो आइडेंटिटी अप्लाई कर दी. 1 + cos x into 1 - cos x divided by this. Now we have some cancellation here. This gets cancelled with this. We're left with 1 + cos x over cos x. Remember what we want to prove at the end? We want to prove that this is equal to 1 + 1 over cos x. इसके equal proof करना है. Are we pretty close to that? Yes, but अब क्या करें? Split this fraction. इसको दो parts में कर लें. You can write this as 1 over cos x plus cos x over cos x. Numerator को split कर लें दो parts में. Now this gets cancelled. ये 1 बन गया, and you have 1 over cos x here. So you can say this is 1 plus 1 over cos x, and that is equal to the right hand side. This is what we wanted to prove. Okay. Any questions? There's another part to this question. क्या हो गया आप लोगों को? ये part कैसे करेंगे फिर? अच्छा मुझे सिर्फ ये बता दें इक्वेशन क्या बनेगी, उसके बाद फिर आप कर लेंगे. Part 2. Do we need to do any substitution here? Quadratic बन जाता है यहाँ पे क्या? या फिर तो वैसे भी हो जाएगा. सबसे पहले क्या करेंगे? What is the equation that we get? Yes. Okay, so आपने ऊपर देखिए आइडेंटिटी क्या प्रूफ किया है. This thing is identical to this. तो नीचे इक्वेशन में देखें आपके पास ये चीज आ रही है, right? In place of this, we could say this is 1 plus 1 over cos x. Is that okay? But you also have plus 2 here. So you got plus 2. This equals 0. Does this make sense? Yeah. So this becomes 1 plus 1 over cos x plus 2 equals 0. This is the equation that we have to solve. Now we can take 1 and 2 to the other side. That becomes 1 over cos x equals -3. Cos x को उधर ले जाएं, 3 को यहाँ पर ले आएं. That's going to become cos x equals -1 over 3. And then you can solve this further. The interval that you have for x is between 0 and 360. You'll find the basic angle. Basic angle इसका क्या आएगा? Basic angle इसका क्या आता है? Alpha. Alpha क्या आता है? Sorry, 7, 72.5, 71.5. 70.5. That's the basic angle. इसके बाद आप क्या करेंगे? कौन से क्वाड्रेंट में? Cos is negative. That's the second or third quadrant. So you could either be here or here. This is 70.5 and this is 70.5. These are the two possible angles. Second quadrant में it becomes 180 minus 70.5. That's this angle. Third quadrant में it's 180 plus 70.5, and you get two values of x. One is 109.5 and the other is 250.5. These are the two answers that you get. The rest you can do yourself, Maniva. This is that we have. Okay, and the second part. ठीक है, अब आपने कल तक क्वेश्चंस प्रैक्टिस करके आने हैं जितने ज्यादा हो सके. अब आप आइडेंटिटीज वाले क्वेश्चंस भी कर सकते हैं. सिर्फ इस तरह के क्वेश्चंस हैं जो आपने अभी तक नहीं किया है. एक तो ये वाले प्रॉब्लम्स, if you look at the top row, tan of 2x plus 15. अगर tan, sin और cos के अंदर x की बजाय कुछ और आ जाए, 2x plus 15 फॉर इंस्टेंस, इसको कैसे सॉल्व करेंगे ये अभी हमने नहीं किया. और ये वाली प्रॉब्लम्स हैं जहाँ पे उसने क्वेश्चन के अंदर बताया होता है tan x equals समथिंग और फिर आपको बाकी चीजें फाइंड करनी है. इसके अलावा बाकी सारे क्वेश्चंस मोस्ट ऑफ देम आप कर सकते हैं जहाँ पे ग्राफ्स भी नहीं है. That's another condition as well. But you can do a lot of the questions from the worksheet. Please make sure कि आप प्रैक्टिस करें और जो प्रॉब्लम्स आए वो फिर हम क्लास में डिस्कस करें. अगर मैं सारे यहाँ पे कराता जाऊंगा उसका फायदा इतना नहीं होगा. ठीक है, खुद से करके आना. ओके, अल्लाह.